Hello, welcome everyone. I'm Van246. This is a very different video. It's not even gaming related. I'm here with my brother's fiance, and we are going to be talking about impossible numbers in math. Or at least what I think count as impossible numbers.
Ooh.
So I've got a little sketch pad. Here's the pen. And I don't know how this is going to show up because I'm recording on an iPad. But the first impossible number I wanted to talk about was 0 over 0. Now, the reason I'm calling it impossible is because there's no way to understand it. Like, what does it do? What do we know that it could do? I've tried experimenting with it.
May I? One thing I learned in school was any number over 0 is a no-no. Because you can't do it. It's impossible.
Exactly. But just any number over 0, like, what can you do with it?
Nothing. It does not exist. In
Right.
calculus, if you were searching for the limit of a number over 0, it would be the limit does not exist. And that's a Mean Girls reference if you've ever seen that movie.
I haven't. But before I transition into the next subject, I wanted to bring up kind of a debate with you and with the whole audience. But but I wanted to ask about 0.9 repeating and 1, or pretty much n.9 repeating and n plus 1, I guess you could say, or n plus 0.9 repeating.
Okay.
So my question is because, like, mathematically it's been proven that they're equal, would you consider 0.9 repeating or n plus 0.9 repeating or 0.9 repeating, whatever it is, would you consider that to be non-existent because it's just 1? Or would you consider them to both be, or would you consider the whole number to be non-existent because this exists? Or which would you consider?
I would consider them to be existing because as far as you can repeat 0.999 infinity, eventually it becomes so small that it will no longer, the smallness of the number away from 1 would eventually be so close that it would touch. And again, this is actually kind of a calculus topic or something we talked about in pre-calculus. Whenever you're drawing limits on a graph, you can get so close to the line that eventually it becomes that number. When it's 0.999 repeating for so long, it can only go so far until it is so close to it that it becomes it.
So what you're saying is that pretty much the difference is so close to 0 that it becomes 0. Well,
Yeah.
isn't that kind of circular reasoning? Because in the sense that 0.9 repeating is 1, 0.0 repeating with a 1 at the end is equal to 0. Isn't that because that's the distance from 1 that 0.9 repeating is. So isn't that kind of circular reasoning? I'm not denying what you're saying. I'm just saying, doesn't that kind of fall back on itself? Like, this distance, there's no way to prove this necessarily. You can prove it because of this, but the only reason that you can prove this is because of this, or at least the way that you're proving it. It's been proven that, it's been proven that this is true, like, mathematically.
Yeah. So I guess the way that you would prove it would be to get out a graphing calculator and graph the limit, and like you said, with the 0.0000 and as many zeros as you can possibly do, 1, when you graph it, the graphing, humans and technology can only go so far. Eventually it would just become 0.
True. So, in a perfect world, they're technically not equal.
Technically, yes. But for
Because we're not in a
mathematic-
perfect world.
Right.
In a perfect world, infinity could exist for all we know.
Yeah, but for mathematical purposes, because you have to again think, why are you using this math? You're using it to solve something. So like if you're measuring a desk and you want to see if the desk fits in your house, if it's 0.99999999999 and it keeps going on and on forever, you would just make it 1 for measurement's sake. So in science, you only need to get so far. Like if in medicine, you want to be as exact as possible, and that could be 10 decimal places. But if it's repeating, it goes on for hundreds and thousands of decimal places that it becomes irrelevant at that point.
That makes sense. So, what if I were to tell you that 100 does not exist? Well,
Mind blown.
100 does not exist
Why?
when written this way. Wait,
Okay.
in Roman numerals, LL is not a valid combination of letters. The
So
way you would write 100 is, I think it's C.
Okay.
So LL is not a valid number, but LL is just 50 and 50, so it's 100. So effectively that's saying 100 is not a valid number in the Roman system, in the Roman writing system.
But you said they would use C, so then it would become valid again. That's kind
Right,
of
but
like...
LL, when written that way, LL is not LL is not valid. LL is not valid. 100 is valid. LL is also 100. It's just not valid that way, I suppose you could say.
So then that would just be like a language barrier, because like in Spanish, if you want to say 21, you would say 21. But to someone that doesn't know Spanish, they might see 21 and say dos uno, because 2 is dos and 1 is uno. But technically, to someone speaking Spanish, dos uno is just 2-1. That is not a valid number. It's just 2 separate numbers, two separate entities. You would have to say 21 for someone to understand that you're trying to say you're 21 years old, for example.
True.
If they ask you how old are you and you say dos uno, they'll say, what are you talking about? That's not a number. That's not an age. You can't be 2-1. You can be 21. You can be 21. So here, that's just the language barrier. If someone doesn't know Roman numerals and they put LL, yeah, it's not valid. It's not a real number. You'd have to put C.
I guess, but I guess this is kind of trailing off of impossible numbers, but couldn't you have, like, through language, couldn't you have impossible scenarios? Like, 21 is 21. So you have 21. But dos uno added together is 3. And here, let me slide this back a bit. And 2 minus 1 is 1. All of those mean the same thing. It's just about how you say it. So doesn't that mean... So couldn't you, with that logic, say 21 equals 3, which also equals 1? And if that's the case, couldn't you abuse that and say if 21 is 20 plus 1, then that means that 21 is also equal to 40, which is also equal to 23.
Yeah.
And why did I write 203? That's
23.
23. See, my own language barrier of writing skill is coming out. So, but couldn't you say 21 equals 3, which equals 1, and then abuse that to say 21 equals 40, which equals 23? If 1 equals 3.
Yeah.
But couldn't you also abuse that and also make it so that it equals 42, now that I think about it.
Yeah. And if
Because
someone-
21 is 20 plus 1. No, it would be 41. You could say that it equals 41. And then you could abuse it from there, too.
And if someone saw this notepad right now, they would think you're a lunatic.
Yeah. And what do you think? Can you think of any impossible numbers or ways to abuse said possible numbers? Impossible numbers? Are there any things that you know from calculus? Like impossible scenarios.
Impossible scenarios.
Like you were talking about limits.
Yeah. So
What is a limit?
a limit is basically a barrier to a slope. Can I draw?
Sure.
So like if you have this and this is 1, 2, 3, 1, 2, 3, 1, 2, 3.
So the limit
1,
of like
2, 3.
so the limit of x minus 1.
So normally it'll be parabolas. So like if you have this graph,
Oh, I kind of remember this from algebra.
the limit would be
-2.
y equals -2.
Oh, okay.
And so then you would write that, you would just write limit is -2.
So what
And-
would you? So if you had like y equals x, the limit of that would be infinity.
Yes.
Or like if you have a straight line
Yeah.
going up, a straight line going
Yes.
down. If
At
you had a
any-
straight,
at any point, if you have a straight line going any direction, the limit would be infinity. Yes.
but what about if it's going that way? If it's going horizontal, that would just mean like it's the limit of that number, right? Like y equals 2.
Yes.
The limit of y equals 2 is y equals 2.
Yes.
That. So what about the limit of undefined? And I know it'll say it's blank over 0. We talked about this at the start. So is there no way to graph it? Because
There is.
wouldn't that just be infinity? Because it does because it's a straight line. It continuously goes up.
I can't remember what the graphs look like for the limits that don't exist, but I know there are situations where you can have multiple limits. Like if you have a graph that looks like this, then you would have a limit here, and you would have a limit here. So those would be your two limits.
Okay.
But I can't remember how to graph the limits of things that don't exist. It would probably be, or if you had a graph like this one also exists. If you had something like that, the limit would be at the peak points.
So it'd be for something that goes, so if you have more than one curve, you could say, like if you have more than one of these, the peaks you can have more than one limit. Like I know there's, may I please? Thank you. I know there's a way to graph. So let's draw. That's a poorly made graph. But say we have a circle. Because I'm pretty sure it's possible to graph a circle, right?
I think so, and maybe actually that would be where the limit doesn't exist. I don't have my phone, so I can't look it up right now, what graphs limits don't exist on. But basically anything where 0 would be in the denominator wouldn't exist.
Because a circle, every point matches up with a corresponding point vertically, which isn't supposed to happen. So a circle is essentially the pinnacle of impossibility on a graph, you could say.
Yeah.
There's probably something crazy with logs of tangents around a pyrogram or whatever it is. But at least by my standards, with just limits, with a circle is the impossibility of limits.
So for that, you'd write D and E does not exist.
Now, here's a third topic that kind of relates to calculus. Actually, it directly relates to calculus. What about derivatives and what's the other one called?
Integrals?
Integrals. Can't you take, like, if you were to take the 0.9 repeating, which we've already discussed, like, the difference becomes so minuscule that it doesn't matter. If you were to take that and square it, this isn't really relating to derivatives, but if you were to take this and square it, what would happen? Because I know if you were to multiply it out as 0.9 forever, and I know that technology has its limits, but I'm saying, like, there has to be a difference, because less than 1 multiplied by less than 1 is always going to be less than 1, like between 0 and 1, I mean. A non-zero, non-negative number that's less than 1 multiplied by anything else that's less than 1 will be less than 1.
So with derivatives, if you're wanting to relate this to derivatives, the derivative of any number is 0. If there's not a...
Right.
Yeah, so you can't... So it doesn't matter 0.999 repeating, the derivative of that is 0.
So really...
If you put 0.9 repeating x squared, then the derivative would be...
It would be...
the formula to find, and then it would be 2 point whatever x.
Right. So,
first.
I guess relating it back to derivatives, do you write div? Like, how do you write saying that this is the derivative?
You can write
Like
dx over dy.
dx over dy equals non-zero number. None of those exist. Because you can't have a derivative of 1.
Right.
You can't have a derivative of negative 1. You can't have a derivative...
Well, you can. It's just 0. So it's
No. I'm
exist.
saying, like, the answer. Like, you said the derivative of any number is 0. There's not a number out there whose derivative is 1. Is what I'm saying. Like, I probably didn't write this correctly.
Well,
but
yeah,
like
yeah.
the derivative of 6 billion x, or not 6 billion x, the derivative of 6 billion is going to be 0. The derivative of infinity is going to be 0,
The
right?
derivative of 1 is 1.
How?
I can't remember, but I just know that it is.
Okay, well then any non-zero...
Non-1. I'm. Don't quote me on this. I'm not a math genius. I mean, I haven't taken calculus in like 5 years, but I'm just pulling stuff out of my head that I remember.
Same here. Because I'm in geometry right now, which is the most unrelated to this topic in the world. Well, maybe not actually.
Yeah.
I mean, we found the impossibility in derivatives. The impossibility is any non-zero, non-1 number. That can't be the derivative, the answer to the derivative question.
Yeah.
I probably didn't write this right.
Yeah. Well, but technically, like I was saying, is like with the limit thing, for the ones that they don't exist, you don't write 0 because the limit isn't 0. You write the limit does not exist. For this situation, you would write the answer is 0. If you have the limit of any, if you have the derivative of any number, your answer is going to be 0. So your answer is not, does not exist. It is 0.
Okay. So, I guess, going back to geometry.
I haven't taken that. since my sophomore year, freshman year of high school. So
I'm taking it right now.
I don't remember it. It's been a long time.
But impossibilities in geometry are a triangle with more than 100 or less than 180 degrees, right?
Uh-huh. Because you you can't be a triangle and have more than 180 degrees.
Would you consider, like, if I draw this, and this is x, what angles are there? Because I say there are two. I say that there are two angles there.
Okay, explain.
X and
the other side.
360 minus x.
Yes.
However, most people don't look at it that way. When people draw that, they only really show that.
Mm-hmm.
Now, would that be considered impossible or non-existent? I don't think it would. However, the case being, what if you have, like, so we're taking so this is like taking a non-existent 361 degree angle. You can't have that. But what if you were to apply that to a problem? If you were to apply that to a problem and say, like, find the supplement of 361. Or rather, let's not go with 181 because that still technically exists. Just not for this case of problem. So if you take the supplement of 361, you just do 180 minus 361, right?
Mm-hmm.
And you're left with negative 181. Even if you were to do the 181, or even if you were doing 90 minus 91, that's negative 1. That's negative 1. So how could you apply negative angles? Negative angles don't exist. How do you apply negative angles to problems? Like, what use could that serve? If it was legitimately possible.
I would argue that, though, because since you can't have a negative angle, like, for example, where you got the 361, and you can't have 361 degrees, I would argue that it's not 361 degrees because your 360 minus x can only be less than 360 because you can't have a minus negative x because there is no negative x angle.
I disagree with that. I mean, I agree with
so
that.
Like right here.
I agree with that. It should be, but at the same time, there's no explicit rule in math or special logic in math saying that an angle of 361 can't exist. It's only the limits of the real world, of our comprehension of drawing. Like, I physically cannot draw a 361 degree angle unless you were to consider that as a 1 degree angle. However, there is nothing in math, to my knowledge, there is nothing in math specifically stating that a 361 degree angle cannot exist. It's like...
Maybe there is. Maybe we just haven't gotten that far yet.
Right. I mean, that's true, but from my knowledge and from your knowledge, because I don't think there's like an extra level to geometry, unless you count physics, which we're not. Which we're not counting physics because physics is where that limit is put into place. But if we're talking in a mathematical dimension where anything is possible, mathematically, of course, then how could you apply a negative angle? How could you apply a 361 degree angle or a 181 degree angle if you're just talking about, well, 181 doesn't really make sense. But a negative angle, how could you apply that? Not to the real world, but to math. Like, if you were to take a triangle, like, I can't draw any of these. I could attempt to. But if you were to take a triangle, you could, in theory, have a triangle that is 180 degrees, 180, for one of its angles, and then negative 90 on each of them. And then negative 90 on the other two. No.
It would have to equal 180.
So you could have 182 then. 182 degree angle, and then the other two be negative 1.
Mm-hmm.
Since that's 182
Yeah.
minus 1 minus 1. That's 180. So how you would even draw
Yeah.
an angle like that, but how could that be applied? Like laws of a not laws of a triangle, but like problems relating to a triangle, like the circumcenter. That's what I'm learning about right now currently. What is the circumcenter of that? That is the distance from each of the sides. Well, we can't, not distance from each of the sides. That's when the three
Distance from-
perpendicular bisectors intersect. So let's just make this 184 for simplicity's sake, so that each of the angles can be bisected. Problem is that these are all physical things, so I can't draw them. But we can try to manipulate. We can try to manipulate the math behind it. So this is like going into negative sides and such. Like negative numbers are really, really bad for geometry. But you've got two negative angles right here. That's really weird to think about.
Yeah.
But you've got negative 2 and negative 2 here. You bisect them, and you have and you have all of them meet up. Now, here's the thing. Honestly, this subject just kind of stops here because there's no way to fit. There's no way to do it physically. I cannot show anything about how to do this
Yeah.
unless
It would just be, it would be, what would this class be? This would be called like a math philosophy class.
honestly I would take that class
Yeah.
because that would literally just let me think about things like this. But I mean, that's kind of what this is: math philosophy,
Yeah.
negative angles. I mean, like I'm asking, how would you draw that? But drawing is just a physical manifestation of the math, right?
Yeah.
I mean, if you list out the information, you can just as easily not draw, but you can just as easily manipulate the math with negative numbers as you can with positive numbers. You can't have a physical representation of it, but you can still have the numbers. Well, I guess I'll have to stop it for here, but thank you all very much for watching. I know this is a different video, but I'm glad y'all enjoy it.
And this is VAM246 coming at you with
Math philosophy.
ba-dum-bum.